Yeah, let's do 16.5, which should help you out with 16.8 for sure, and 16.6 should you choose to do that. I believe that one's an optional one if I'm not mistaken. Yeah, it looks like that would be kind of a bonus one. So in any event, here we go. So it makes sure that you do, when you do these on page 578, that you use the top in the box, where you use A, B, C, D, and E. Make sure you do that. Okay, do those in that order, just like I have it here. So first we have to state the hypothesis, and for mine, for number 5, it says that we had a 45 overweight guys that went on an exercise, and 32 of them lost weight. Can we conclude that it was effective? So it'd be effective if more than half of them lost weight. Okay, actually, probably be effective even if just a few of them lost weight, but nonetheless, 0.5 is what we're shooting for, right? And so my alternate hypothesis then is kind of based on that statement, is that my probability, or my p, my pi, is greater than 0.5, which makes my null hypothesis less than or equal to. Okay, and I'm going to reject if z is greater than 1.645 using my handy dandy little deal there, right? Come up to, so it's 95. Okay, and I'm on a one-tailed, so I'm going to reject if I get out in this region. 94.5, if I can go a little further, it'd be 95.05. So 1.645, 1.65, you could use either of those, would be okay. And then I've got to do, which equation do I use? There's the 3 equations there on 576, kind of in the peach colored there towards the bottom. And the main equation just says that z is equal to x plus or minus 0.5 minus my mu, okay, divided by my standard deviation. And so how do I know which one to use? Well, I use I have to figure out, if my x is greater than my mu, basically is what that amounts to, right? Okay, if my x is greater than my mu, I actually use the minus in here, then it's x minus. Okay, and you can see that it says sign test n is greater than 10, so if I have an n of greater than 10, and I have plus signs that are more than n plus 2, or n divided by 2, I'm sorry, n divided by 2, which is same as saying 0.5 times n, right? So if my x is greater than my mu, then I use the minus. Okay, so my z is going to be equal to, for my equation, x minus 0.5 minus the mu divided by my standard deviation, which is 0.5 times the square root of n. Okay, so I plug in my numbers, right? My n's 45, my mu is 0.5, or 45 divided by 2. Okay, I guess you could do that either way. My x is 32, which is given to me. My standard deviation, I just went ahead and calculated, is equal to 0.5 times the square root, there it is, square root of my n. Okay, so I got that. And then this part I can kind of do in my head. My x is 32, and I said it's going to be minus 0.5, so I got 32, so I got 31.5 minus 22.5, so it'd be 9. Okay, I just put the rest of the equation in here after I'd calculated my standard deviation for the bottom. But basically it's going to be equal to, right, 9 divided by, and you guys should show your work, this, my standard deviation, and there you have it. Okay, and so 2.68328 is greater than that, so I reject the null. Okay, I reject the null, and instead I say that's my answer, but then to interpret, I should actually put this, that the exercise program is effective. Okay, I say that the exercise program is effective, that there's almost no chance that 32 losing weight was a random thing. Okay, so instead I can interpret that it was effective. So there you have it.